Assalamualaikum and hi, my name is Ferrarina binti Fauzan. My matrix number is CD240022 and today I will explain the theory of balancing of rotating masses. So when a mass rotates about an axis, a centrifugal effect is produced. The magnitude of this effect is proportional to the product of the mass and its radius of rotation, which is represented by mr. If the resultant centrifugal effect is not zero, the rotating system becomes unbalanced and vibration occurs. For single plane balancing, all rotating masses lie in the same plane. Static balance is achieved when the vector sum of all mass radius products is equal to zero, which is sigma mr or summation mr equals zero. A closed vector polygon formed by the mass radius products indicates static balance. In practical rotating system, masses are distributed along the shaft at different axial positions. In this case, dynamic balance is required in addition to static balance. Dynamic balance is achieved when both the resultant centrifugal force and the resultant moment about a reference plane are zero, which are sigma mr equals zero and sigma mrl equals zero. When these conditions are satisfied, the rotating system operates smoothly without vibration.
Hi, my name is Ahmad Irfan Iskarno. Now I will be presenting results. So for experiment 1, the theoretical condition is the same as the experimental condition. Most of them are balanced, and they also have a perfect alignment because the positions of the weight are balanced. And for experiment 2, it has two states, which are static and dynamic. So the theoretical condition has a few differences from the experimental condition. For static, theoretical and experimental are the same, but in dynamic, only at experiment C is different. So it means reliability in static states, slight variation in dynamic states.
Hi, my name is Colin Teo. My part is observation. Initial visual inspection. Observe the initial arrangement and position of the rotating masses before operation. Second, behavior during rotation. Monitor the system for wobbling, vibration, or instability while rotating. Next is vibration characteristic. Assesses vibration amplitude and frequency as indicator of mass imbalance. Next, quality of rotation. Evaluate the smoothness of rotation and listen for unusual noises that may indicate imbalance or miselement. Next, effect of mass adjustment. Observe change in vibration and stability after adjusting mass position. Lastly is irritative balancing process. Recognize that achieving optimal balance require repeated adjustment and observation.
Hello, my name is Adam Aziz and now I'll be talking about the discussions. So basically for question number 1, explain the results obtained for the balancing of rotating masses for single plane. From during experiment A, there was only one mass placed, so there was no so unlike experiment B to F, there was no mass counteracting that single mass from experiment A, so it recorded an imbalance condition, while B to F there was forces counteracting, so it was balanced. Now for question number 2, explain the results obtained from the balancing of rotating masses from multiple planes. From experiment A, we can see the result showed a static balance but dynamic imbalance. B and D also achieve B and D achieve balance in both static and dynamic. So basically experiment A, B and D followed the theoretical calculations or the theory of this experiment, while on the other hand, experiment C, the theoretical calculations showed that it should be balanced, but during the experiment we recorded that experiment C had a dynamic imbalance. We assume that it's because, or it occurred because there was likely an experimental error such as slight misalignment of the angles or measurement or maybe even a measurement inaccuracy. Now for the last question, give an example of the application of balancing of rotating masses in real world applications. First is in the automotive industry. Car wheels must be perfectly balanced. Any imbalance or any slight imbalance, I would say, could cause the wear in the tires and also compromise the vehicle safety. Now, secondly, are gas turbines or jet engines. So basically, the rotors in the engines or gas turbines spin at very high speeds. So even a microscopic imbalance could cause massive destructive forces.
Hello everyone, my name is Dayangku Zahiratul Akila and today I will be presenting the conclusion of our experiment on the balancing of rotating mass. To conclude, this experiment successfully verified the principles of both single plane and multi-plane balancing. For single plane balancing, we observed that balance is achieved when the vector sum of the mass radius products is equal to zero. When this condition is satisfied, vibration caused by unbalanced centrifugal forces is effectively eliminated. In the case of multiplane balancing, the experiment showed that static balance alone is not sufficient. Both static and dynamic balance must be achieved to ensure smooth and stable rotation of the system. We also noticed small differences between the theoretical and experimental results. These differences were mainly due to measurement error and minor mechanical imperfections in the experimental setup. Overall, proper balancing is very important because it reduces vibration, lower bearing loads, and increases machine lifespan. This is especially critical in applications such as automotive systems, engines, turbines, and other high-speed machinery. In conclusion, this experiment highlights the importance of balancing in ensuring efficient, safe, and reliable machine operation. Thank you.